Hi everyone, it's Coach Fred, and so today we're going to be looking at an introduction to the unit circle, and this is going to be something that we're going to use for the rest of this unit on trigonometry, and it can be confusing when you first get started with it, okay? So let's start by understanding what it is. A unit circle is a circle drawn in the coordinate plane with a radius of 1, okay? So it should make sense, unit circle. Remember you used to do like unit rates? And it was when you were getting the basic rate for something in terms of 1. So a circle with a radius of 1. So here I've drawn it, and it's got to have its center at the origin, which you can see. And so it's really important to understand that circles, when they're drawn in the origin, you might be trying to find points on the circle, like coordinate points. They also we can ask you for angles rotated around the origin. So, for example, this point P, it has an angle from here to here, and it also could have a coordinate, an x and a y, okay? Now, when we draw angles in the coordinate plane, we're going to be drawing them in what we call standard position. That means we're always going to start on the positive x-axis, and we're either going to go up this way, which we would call the positive direction, or down this way, we'd call that the negative direction. So everything's going to start on the positive x-axis, go up, or go down. Okay, so now you have to also see that if you start in standard position here, then you might have to go around. You could go around here. You could go around here. You could go around here. And you could actually keep going all around and around and around because it's a circle. So angles that are in a circle, rotations, they're really rotations, can go bigger than 180, they can go bigger than 360, they can go bigger than 1,000. And so we want to keep that in mind when we're working with this circle, okay? Now, another interesting thing about the circle is that if I want to try to use find the coordinate point, that's where the Pythagorean Theorem can help us. So for example, I can actually drop what we call an altitude. Remember, an altitude is a perpendicular segment straight down. And you can see now that I have a triangle. And so if the radius is 1, I can use that information, this is x, this is y, to find either the angles of the triangle or to find the sides of the triangle. All right, we're going to get back to that in a second, but let's look at what trigonometry is. If we broke it up into parts, trigonon and metron really means measure. Trigonon means triangle. So we're going to be talking about measuring triangles. It's a really basic definition. Trigonometry is used in so many different things. It's used in surveying. It's used in trying to find heights of things. They use it in radio waves, so many different applications to trigonometry. It tends to be my favorite topic to talk about. So, all right, in trigonometry, an angle often represents a rotation around a point. So when we're talking about the unit circle, that point is always going to be the origin. I'm rotating around the origin. So we got to get some language down. There's going to be a lot of language with trigonometry. The first is going to be the initial ray. So the initial ray is the ray in standard position, starting at the x-axis, so we would call this the initial ray. And then we would go to what we call the terminal ray. And in trig, we don't really use x all that much. The angle, when we're talking about the angle, we give it the Greek letter theta. So this would be theta. So that would be angle theta. And I could draw that in the coordinate plane. I don't necessarily have to, but I could, okay? So again, I will remind you, angles shown in the coordinate plane are often shown in standard position. It means the vertex is at the origin, the initial ray is the positive x-axis. Okay, so that's a little bit about the unit circle in trigonometry. Now we're going to use it to find some of those coordinates. Okay, so, oops. Okay, sorry about that. Okay, so if we want to find the coordinate of a 30-degree rotation, so you can see that I can see my initial at standard position and my terminal ray on the unit circle. The first thing that you could do is drop an altitude. Okay? Recognize that this is a 30, 60, 90 triangle. I'm going to pull it out so you can see it. So I have a 30, 60, 90 triangle. I have to remember that my relationship is that the side opposite 30, the short leg, is half of the hypotenuse. So this would be 1/2. And then the side opposite 60 would be 1/2 root 3, which we write as root 3 over 2. All right, so that tells me that this segment right here is root 3 over 2. This segment right here is 1/2. So this would be my x-coordinate, and this would be my y-coordinate. So root 3 over 2, 1/2. Okay, I want to recall something here. I want you to recall that we found the sine of 30 earlier, the cosine of 30, and the tangent of 30. Okay, so we said that the sine of 30, go back and look if you need to, the sine of 30 was 1/2. If you look at this triangle, opposite over hypotenuse, 1/2 over 1, it would be 1/2. The cosine of 30 would have been adjacent over hypotenuse, which we worked out to be root 3 over 2. Again, important values. And then the tangent we worked out to be root 3 over 3. What I'm hoping you notice is that the sine of 30 is actually the y-coordinate of the point. And the cosine of 30 is actually the x-coordinate of the point. So the cosine is going to be, the point is going to be the cosine's ratio at that value, that angle. And the y is going to be the sine's value of that angle. And that will always be true, okay? All right. So what I have to make you understand is that this is the coordinate point. The angle measure at that point, though, is 30 degrees. Now, I also want us to write the tangent on the outside. So we're going to write the tangent as root 3 over 3. So we're getting used to these values. Now, what's really cool about this is I can actually reflect that triangle into quadrant 2. Now, if I reflect it into quadrant 2, then this coordinate, the only thing that's going to change about the coordinate is the x is going to become negative because x's are negative in quadrant 2. Now, the difference is, though, I wouldn't be looking at a 30-degree angle. I'd be looking at the angle from standard position to the terminal ray, so that would be 150 degrees. So the degree measure at this point is 150 degrees, okay? Now, I could keep going. I could reflect it into quadrant 3. This is 30 degrees. What would happen to the coordinate point is that they would change to both being negative. That would actually make the tangent positive, okay? But the angle measure there would be 180 plus 30. Because again, I'm starting in standard position. I know it's getting messy. And I'm going all the way around here. So 180 plus 30 would have me at 210 degrees. All right, I could reflect the first quadrant one into the fourth quadrant. Again, this would be 30. Notice all the little angles on the inside are together. So my coordinate point then would be positive x, negative y. But now my angle would be, if I started in standard position, go all the way around, it would be 360 minus 30, which is 330. Again, these are going to be angles we're going to need to know in a few days. So starting to get used to where they're coming from is really helpful, okay? All right, let's move on to a 45, 45, 90. I'm going to ask you to press pause and see if you can come up with the coordinate points on your own. Okay, so you're back, and so I hope you dropped your altitude, recognizing it's an isosceles right triangle. There's that special right triangle we worked with yesterday. If you have the hypotenuse, you divide by root 2 and then rationalize to get root 2 over 2. These would both be the same because the triangle is isosceles. Okay, so this would be a 45-degree angle. So that's the rotation. The coordinate point is root 2 over 2, root 2 over 2. And the tangent at this value would be 1. All right, if I reflect it, I would be over here. The only thing that would change would my negative x's, positive y's. So negative root 2 over 2, root 2 over 2, quadrant 2. That would make tangent negative because one of them's negative. So tan would be -1. Okay, this angle would be 45. So the angle of the rotation would be 180 minus 45, which would be 135. All right, I could reflect it again into quadrant 3. So both of them would be negative. So -√2/2, √2/2. So that would make the tangent what? Positive. So it would be tan would be +1. All right, so then this angle right here is 45. So I'm actually looking for this entire angle. So I would do 180 plus 45, which would give me a rotation of 225 degrees. So if I was looking for the sine of 225 degrees, I need to recognize I'm in quadrant 3, and then the reference angle is 45. We call that 45 a reference angle. I'm going to talk more about that soon. Okay. And then the last angle we want to try and get would be in quadrant 4. Again, this would be 45. My coordinate point would be x positive, y negative, and then the angle would be 360 minus 45 because it would be all the way around here. All right, and that would give me 315 degrees. The one thing about the unit circle is that all the ones that have a 5 in them are going to actually be the 45-degree reference angle, which makes it kind of easy to recognize, okay? All right, one more. 60 degrees, okay? So I'd like you to try it, and we'll come back and talk about it. So press pause. Okay, so hopefully you were able to find that this length here is 1/2. This is √3/2. So we get our coordinate point of 1/2 √3/2. And then the tangent here would be √3. So let's write that in. Okay, but remember, this is a 60-degree rotation. So if I reflect that, I'm going to be at 60 degrees right here. The coordinate point, x negative, y positive. So then tan would be negative. But the rotation would be 180 minus 60, so it would be 120 degrees. Okay, if I do that again, I go into quadrant 3. The reference angle again is 60, but both x and y are going to be negative, so -1/2, -√3/2. Tangent's going to become positive. All right, but what would the angle be? 180 plus 60, so 240 degrees. Hopefully you're seeing this, and this might be one you go back to. And then the last angle would be in quadrant 4. Oops, terrible triangle, sorry guys. And so my coordinate point would be x positive, y negative, tan negative. And then the angle would be 300 degrees. All right, I know that was a lot. I know this is a long video. I apologize, but I wanted to get through all of 3 of those. So now we can kind of put this together. 30, 45, and 60 are the reference angles. If you know them, you'll know all the other angles in the circle. So you really only have to know these guys, okay? So let's recap them, okay? The sine of 30, 1/2. 45, √2/2. The sine of 60, √3/2. The cosine of 30, √3/2. The cosine of 45, √2/2. And the cosine of 60, 1/2. Tangent, 30, √3/3, 1, and √3. Be prepared. I might quiz you on these. I do love to give pop quizzes so we get these because these are going to be important. They are like our algebra math facts. We have to know them. Make index cards. Get them into your brain. All right. Have a great day.